Hey, it's Mr. Barr, and today we're going to do domain and range of graphs. Let's get going here. So our goal is I can use the graphs of functions to describe real-life situations, and graphs are all around me in the world, and I want to be able to understand and create them. So let's get ready with our notes here. Get out your notebook, and we'll start with today's topic, which is domain and range of graphs. So you're going to start with your name, which is how we normally do it, name. And today's title, which is domain and range of graphs. Domain and range of graphs. We did domain and range a couple lessons ago, and we're going to keep working with that, and today we're going to apply it to graphs. So we're going to learn a new thing. It's called interval notation, and it's kind of how to show things on a number line in a new way. So let's get this into our notes also. Interval notation. Interval notation. And so let's look at a number line here, and I'm going to change it up a little bit. So here's a number line. We'll put a 0, and we'll go from -3 to 2. And on this number line, I'm going to make -3 an open circle and 2 a closed circle, and I'm going to shade everything in between. So -3 is not part of the solution, but 2 is part of the solution. And here's how I can show it using interval notation. -3 to 2. The parenthesis is an open circle, and the bracket is closed. So just like the circle types, the parenthesis is an open circle and the bracket is a closed circle. So when I look at this guy right here, this would be -infinity to -1, -infinity to -1. It's closed at -1, and it's always open at infinity. Infinity is always going to be an open circle because we can't really get to infinity. Let's put that into our notes. Infinity is always an open circle. So if I wanted to say, hey, -infinity to infinity, this would be -infinity, -8. How about that? -8 to +infinity. And notice it's always an open circle with the infinities. So this is interval notation, and it's a way of showing information. So this would be -2 to 4. -2 is closed, 4 is open. Open circle, open circle. So this is 0 to 8, open circle, open circle. This is 0 to 8, closed circle, closed circle. This is -infinity to infinity, open circle, and infinities are always open. All right, so now that we talked about interval notation, let's do a quick reminder of domain and range. I'm getting my notebook ready. I lost a paper, but we're good. So let's remember what domain and range is. Domain is the in, range is the out. Usually we think of domain as we put in x's, we get out y's. We put in x's, we get out f of x's. So we've got domain and range, ins and outs. And now this is the new one. Smear ink onto x. And this is going to be smear onto y-axis. And that will make sense in a moment. This idea of smearing something onto the x-axis or smearing it onto the y-axis. So we're going to find the domain and range of this. It's a parabola. Now, if you have different colors, that's going to be awesome. So in your notes, we're going to do one graph, and it's going to be a parabola. Doesn't have to be perfect. There's a coordinate system. And there's the parabola. Now, what we're going to do is we're going to pretend like this is wet ink. And imagine if I hold the paper up like this, how would the ink go onto the x-axis? This orange ink, if this was my graph, if I tilted it like this, or if I tilted it like this, if I tilt it and this ink runs down, or if I take this wet ink and I smear it, it's going to cover up all of the x-axis. This ink from this graph would cover up everything right here. That's the domain. The domain is negative infinity to infinity. Now, if I took it that exact same graph, and this time I let it like wet paint drip down onto the y-axis, I go like this and I go like this, or I take it and I smear it onto the y-axis, that is the range. And in this case, this is at 2. So it would be 2. Actually, it's solid. It's a solid circle at 2. 2 to infinity is the range. That's it for the notes, but I'm going to do a whole bunch of these with you now. So let's start with this one. If I take and I draw on this thing, and I really take this graph and I smear it. So I'm going to do a whole bunch of smearing. Ready? I take this and I smear it down, and I smear it down, and I smear it, and I smear it, and I smear it, and I smear it, and I smear it. And this, remember, this thing keeps going up and up forever, and I keep smearing it. I keep, right there. That's my domain. Now I start smearing it sideways. So I take it right here, and I smear it, and I smear it, and I keep smushing it, or I smear it. It's going to cover this, and that is the range. So my domain, I already wrote this down, but it is negative infinity to infinity, and my range is 2 solid to infinity open. Let's do another one. There's the answer to that one. This guy. So imagine I take this ink and I drag it up here. It's going to be right there. And if I take this point and I put it up there, I mush it, I smear it. I take that and I smear it. And all this ink runs to here and here and here. And then on this side, it runs down and down and down. Notice it's going to cover up everything. And then when I let the ink go this direction, ready? Ink, 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 ink. It's going to cover up everything here. So my domain is everything, and my range is everything. We also sometimes write this as all real numbers. All real numbers. That's the symbol for, let's get that into our notes. That's the symbol for all real numbers. All right, let's do another one of these. So all real numbers, all real numbers. So I'm going to take this and I'm going to mush it down onto the x-axis. So I mush it, I mush it, I mush it, I mush it, I mush it. So I have solid at 0, right? It actually touches 0, so 0 to positive infinity. And here, there's my range, which is, once again, it's solid at 0, 0 to positive infinity. Zero to positive infinity, 0 to positive infinity. Okay, this one's a little bit different. Let's take a look at it. So if I take this point right here and I drag it down, it's covering this up. Remember, this keeps going over, so it keeps dragging. It goes all the way over here, right? Covers it up, 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 covers it up. Keep dragging it down. So look right here. There's nothing right here. There's no paint right here, so there's nothing to drag down or smear down. So this is actually all real numbers except what? Except 4. And here, let's see, I smear this one this way, I smear it, I smear it, I smear it. This actually covers up everything over here. I know this one doesn't smear this way, but this guy is right there already. There's red right there. So this is going to be solid 3 up to infinity. That's the range of this. So our domain is all real numbers except for 4, because notice 4 isn't covered. And our range is 3 to infinity. So here we go, x cannot be 4, and 3 to infinity. All right, let's do this one. All right, let's start smushing things down. So see this guy? Yeah, he's covering up this. Yeah, we're 4 is covered here, and 4 is covered up. Nope, it's got to stop right here though, doesn't it? Because then there's this gap, and now we can start smearing stuff down again. So we actually have a couple pieces here. Right here we have negative infinity to 1. And then there's this gap, and then it picks up at 1. Actually, this is negative 1, isn't it? Negative 1 right here. And then it picks up right here at 1. And it goes to positive infinity. So there's the domain. What about the range? Well, let's see. smush it, smear it over, smear it over, smear it over, smear it over, smear, 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 smear. Well, the range is right there, and it's going from negative infinity up to positive 2. So we had negative infinity to negative 1, 1 to infinity, and then negative infinity to positive 2. Oh, let's talk about decreasing and increasing. This is going to get into our notes. So in our notes, we're going to draw another coordinate system. We'll put a parabola on it. This is decreasing. We read a graph from left to right. So as I read this, it's going down. And then as I keep reading, it's going up. So this is decreasing. And over here, it's increasing. And when I look at a graph or a piece of a graph, I should be able to determine if it's increasing or decreasing. So over what interval is this graph increasing? Well, it's increasing right here between 0 to infinity. And where is this graph decreasing? It's decreasing between negative infinity and 0. Increasing from 0 to infinity, decreasing from negative infinity to 0. What's it actually doing at 0? At 0, it's not increasing or decreasing. It's just at 0. So let's do this one. On what interval is this thing increasing? Well, it's increasing from 0 to positive infinity. Right? 0 to positive. Where is it decreasing? Well, this thing is never decreasing. Remember, I always read a graph from left to right. This is always increasing. Where is this thing increasing? Well, it's increasing right here. It's increasing right here. It's increasing right here. So is it increasing from -8 to -5? That's a place where it's increasing. Or it's increasing from 5 to 8. Where is it decreasing? It's decreasing right here. It's decreasing right here, it's decreasing right here, and it's decreasing right here. So let's talk about this one. It's decreasing from from 2 to 4. 2 to 4, it's decreasing. -4 to -2, it's decreasing. And that's the last slide. I will see you in class. Thank you for watching.